So, you know the topic for today's session. So our plan is to revise random variables and random process in the next 4 days. So I'll try to cover all the important topics. Uh, I'm gonna assume that you have some basic idea or you have decent preparation in random variables and random process. Assuming that, I'm gonna take this session. Okay. So since this is a revision course, I'll not be discussing very basic stuff. Okay, but I'll be touching upon all the important things, and we'll be doing some interesting questions also. So in the process of solving these questions, you'll be able to observe all the concepts. If at all, if there are any misunderstandings also, you'll be able to correct it. Right. So the topics that we'll be discussing today. So today is my first class on YouTube. So it's a small things are new to me here. So that's why a little bit of delay. So I hope you'll understand that. Right. Okay. Right. So I'll be discussing about probability density function, which in short we call it as PDF, and we'll also be discussing about CDF, cumulative distribution. We should call it as distribution function, cumulative distribution function. That is the right word to use. So which we in short we also call it as CDF. And the most important thing about PDF and CDF is first of all understanding what is the meaning of PDF and CDF, and then understanding their properties. So in any topic, properties of any particular function is really important. So questions will be framed based on these properties only. Okay, right. So and now once we revise these thick topics PDF and CDF, we'll be discussing problems based on PDF and CDF. And after that, we'll be talking about moments, which we also call as expectations or averages of a random variable. And we'll be dealing with interesting problems on random variables. Okay, right. So before starting all of this, so our discussion is regarding random variables, right? So I want to give a brief idea about random variables. Right. Random variable. Right. So what is a random variable? So you might have learned about variable, right? You might have the very important variable that we know is variable x, which we use in mathematics, variable y, which we use in mathematics, right? You can use some other letters also, but generally we are used to using x and y. Okay. So, and one more important variable that we will be using in our engineering courses is time variable, right? What is the difference between that variables that we discuss in our other courses and this random variable? Okay, there is definitely a difference, but there is some common thing also, right? Because both are being called variables. Time is a variable, x is a variable, y is a variable, right? But here we're talking about random variable. As the name says, variable means it takes various values. It takes various values. But the difference between the variables t, x, y, let me name them. So this x variable that we talk about, y variable that we talk about in mathematics, and t variable we talk about. So these are all deterministic random variables. That does not mean that anybody says x as a variable. That does not mean that it is always a deterministic random variable. I'm talking about the variables that we talk about in mathematics. On x-axis whatever we plot, on y-axis whatever we plot, those things I'm calling it as deterministic variables. Deterministic means what? We can determine the values. After x takes 1, we know that after 1 it takes 2. If x takes only integer values, after 1 it takes 2, and after 2 it takes 3, and after 3 it takes 4. We know what value it takes one after another, right? We know it, we are able to determine them, right? We know it very clearly. Determining means we know it clearly. That is what I mean by deterministic. Similarly, time. After 1 second, what happens? 2 seconds will happen, 3rd second will happen, 4th second will happen. So the values taken by the variables, if we know them one after another clearly, we call them as deterministic variables. But generally we don't use deterministic variables. The word deterministic variables is only use the word variables. Okay, right. We only use the word variables, but they're actually deterministic variables. So in many other subjects, there will be no discussion about random variables. There will be no discussion about random variables. So what is a random variable? A variable means which takes various values, which takes all real values, non-deterministically you can say, or in a random manner. Non-deterministically or randomly you can call, is called random variable. Okay, let me spend some time here, though it's a revision session. I want to spend some at least 5-10 minutes on this, because everything that we are going to discuss in the next 3 classes, next 10 hours, random variables, random process, everything is dependent on this word random variable. Only once we can digest what is this random variable, once we have perfect clarity on random variable, then only we can understand things more clearly. Okay, right. So how do we denote this random variable? We can also denote it as x, y, z. We can use any letter. Okay, we can use any letter. In our textbooks, generally they use the letters capital X, capital Y, capital Z. That does not mean that we should only use capital letters. You can use small letters also. But generally followed notation in textbooks is capital letters. But small letters also can be used. Right. So I'll give you one more way of understanding random variable. Okay. One more way of understanding a random variable. A random variable, I have given you a rough idea about what is a random variable. A random variable means a variable which takes multiple values, but in an uncertain way. Let's say if x takes value 1, after that, what value it takes, we don't know. It happens with a probability. You are not able to determine what values will be taken by a random variable. That's why we are calling it as random variable. Any variable whose values you are not able to determine, we call it as random variable. Okay, and we can also understand random variable in another way also. A random variable is a function for which domain is sample space. I hope everybody knows what is sample space. Domain is sample space, and range is real line or real numbers, you can say. So you might be aware of this, right? Let's say you might have learned this in mathematics also. Let's say there is a function f. Function f is from a to b. They say f is a function from a to b. This is how we define it, right? In mathematics, this is the notation that we use. Let's say 1, 2, 3 we are using, and abc we are using. We do this kind of mapping, right? So similarly, random variable is also like a function f, but the domain is sample space, which we denoted with s, and the range is a real line, which means real numbers, all real numbers. Real numbers means all the values from minus infinity to plus infinity. So range is what? All real numbers, minus infinity to plus infinity, minus infinity to all the way to plus infinity. There are infinite values in the range. But in the sample space, let's say I'm taking a simple experiment, let's say die experiment. Okay, in the die experiment, what happens? Only 6 values will be there. 1, 2, 3, 4, 5, 6. So these 6 values we can map in a function. We can do one-to-one mapping or many-to-one mapping. So 1 we can map onto 1, and 2 we can map onto 2, 3 we can map onto 3, 4 we can map onto 4, 5 we can map onto 5, 6 we can map onto 6. Okay, we can map like this. So what are the values? This function is taking f of 1 equal to a here, f of 2 is equal to b, f of 3 is equal to c, right? In a similar manner, the function is taking values a, b, c, right? Similarly, the random variable function here, x is a random variable. As I defined in the previous slide, random variable is a function for which domain is sample space and range is real line, right? So what are the values taken by the random variable? In this case, don't say it is taking only values from 1 to 6. It is taking all the values from minus infinity to plus infinity. Always any random variable will take values from minus infinity to plus infinity. But since the probability of 1 is 1 by 6 in a die experiment, probability of 2 is 1 by 6, the same probability, because mapping is 1 from 1 to 1, random variable x takes 1 with the probability of 1 by 6 because this one is mapped onto this one. But if you are mapping in a manner that 1 is mapped onto 1 square, 2 is mapped onto 2 square, then this probability of this one is carried onto 1 square, 2 is mapped onto 2 square, 3 is mapped onto 3 square. Okay, so whatever mapping we are doing here, the same probabilities will be carried to those numbers, those real numbers. Right. So x equal to 1 happens with the probability of 1 by 6. Similarly, x equal to 2 happens with the probability of 1 by 6, and so on. So how about probability of the remaining numbers? Probability of 7. Random variable will take those values or not? Yes, random variable always takes all the real values, but certain values it takes with non-zero probability, and certain other values it takes with 0 probability. Okay, I hope it is clear till this point. Yeah, sure, definitely. Definitely, I'll share the PDF in my Telegram group. So you can search electronics by Dinesh Gutha, sir. Or some of you who are already in the group, you can share the link if possible in the chat box so that other people also can access the PDF. Okay, definitely I'll share the PDF. So I hope everybody got some decent understanding about random variables. Since this is a revision class, I'm not able to take more examples. I'm taking only one example and I'm trying to explain. So I believe you got some commonsensical idea of what is a random variable. Very good. Now let me start with the discussion of right. So we have understood what is random variable. Now let us understand what is probability quickly. and I also want you to understand properties of probability. So you all know what is probability. Probability is the possibility. How much possibility is there for a certain outcome to happen? So for example, if you are tossing a die, there is a possibility of happening 2. There is a possibility of 3, 4, 5, 6. With what what is the chance? What percentage chance you have to get 2? That percentage, instead of percentage, you are telling it on a scale of 1. Percentage is on a scale of 100, right? So probability is on a scale of 1. Okay, right. So since you know what is probability, I just want you to understand what is the property. What are the properties of probability? The first property of probability is probability of any event. Always we'll talk about probability of events only. Event means any occurrence. Whenever you do any experiment, any random experiment, anything that happens out of that experiment, we can call it as event. Okay, anything that happens. So whatever comes to your mind, you can call that as an event. Okay, so probability of any event. Let me say A is an event. Probability of any event. What are the range of values that the probability can take? That is the most important probability. Probability can never be negative. It can be 0, but it can never be negative, and it always can never be more than 1. It always should lie between 0 and 1. Any event probability should be between 0 and 1. Wonderful. Next, one more important property. The same properties will be carrying forward to PDF and CDF also. So the next property is sum of probabilities of all possible outcomes. All possible outcomes of any experiment, you can say, or all possibilities. All possibilities or all possible outcomes. Sum of probabilities of all possible outcomes is equal to 1. This looks like a very simple statement, but very, very powerful statement. Is equal to 1. Okay. So for example, if you're taking a die experiment, what are the possible outcomes? 1, 2, 3, 4, 5, 6. If you take the probability of 1, 2, 3, 4, 5, 6 and just add them up, definitely that should lead to 1. Okay. So these properties, we will try to carry forward the same properties to PDF and CDF, because PDF talks about probability only. CDF also talks about probability only. PDF is what? Probability density function. It's a function of probabilities. CDF, cumulative distribution function, is also a function of probabilities. Okay, so let us understand clearly about them. So if you can understand this PDF and CDF clearly, conceptually, if you can understand them clearly, then nobody can stop you from doing any problem given on that topic. Conceptual understanding is very, very important here. Probability density function. As the name says, it is a function, right? Is it a function or not? It's a function. It's a function of what? Function means there's a domain should be there and the range should be there, no? So if probability density function is a function, PDF, in short I'm calling it as PDF. If it is a function, what is the domain and what is the range? Can anyone tell me this? What is the domain and what is the range? So what is the domain and what is the range? Anyone? Wonderful. Range is 0 to 1. Okay. Okay, fine. Definitely range is 0 to 1. That's a fair answer. That's not perfect money. I'll come to that. So means most of the cases that is correct only. So in PDF, the domain is random variable values, correct or not? The domain is random variable, the values of the random variable you can say, and the range will be probabilities. Probabilities of all those values of random variable. Random variable takes all the values from -infinity to +infinity, right? And those values of random variable They are random in nature, means they'll have probabilities, right? X equal to 1 will take certain probability, x equal to 2 will take another probability. So this PDF function, let's say x is a random variable. If x is a random variable, the notation for probability density function can be like this, fx of x. This is one type of notation. That does not mean that if somebody does not write the notation like this, that is not PDF. It's not like that. Notation can be anything, okay? So whoever wants to take whatever notation he likes to take, he can take that notation, okay? So don't bother about the notation, because there will not be any confusion in notation, because in problem, if they are giving you about PDF, they'll clearly mention it is probability density function. What letter they are using for that PDF notation, that should not matter for us. Generally taken notations are this one, fx of x or f of x. Sometimes they'll take it as p of x. Sometimes they'll take it as px of x. Generally, these are the four notations that they will take. But if they take some other letter also, that should be fine for us. We should not get confused. Okay. So PDF, let me take this notation, f of x, fx of x. Random variable is x, and probabilities. The probabilities, yeah. Finally, this is also a function. Function means there will be mapping, right? Probability density function consists of the probability information of each and every value of random variable. Random variable takes multiple values, and for all those values, with what probability that value is taken. X equal to 1 is taken with how much probability? X equal to 2 is taken with how much probability? All that information will be there in this PDF probability density function. Okay, so let me plot a graph. So a random variable, it can be discrete also, right? It can be continuous also. Try to understand this carefully. I told you that random variable takes all the values from minus infinity to plus infinity, which means it's like continuous values only, no? It's like continuous values only, no? Which means will it be always discrete, or will it be always random? Will it be always continuous? I'll tell you. It depends on how is the random experiment. For example, if you take a coin experiment or a die experiment, sample space is discrete now, which means only countable number of values 1, 2, 3, 4, 5, 6, only countable. Countable means discrete. So if those 6 values in die experiment sample space are mapped onto 6 values in the random variable, not more than that. Only 6 values of random variable have some probabilities, other values are not having probabilities. Okay, so the random variable with non-zero probability is taking only finite values, only countable number of values, right? So that is a discrete random variable. A discrete sample space always creates a discrete random variable. Continuous sample space can create a continuous random variable. Okay, so random variable can be discrete or continuous. So probability density function understanding is slightly different for continuous random variable and discrete random variable. What are those differences? We will understand in the next slide. Right. So if I talk about fx of x, okay. So if I am talking about discrete random variable, let's say I am talking about die experiment. At 1, it will have a probability of 1 by 6. At 2, it will have a probability of 1 by 6, and so on till 6. And if you observe the properties here, all the probabilities are less than 1, and some of the probabilities will be equal to 1. 2 properties should be satisfied, right? So this is one example. I'll take one more example. Let me say there is a random variable which takes all the real values from 1 to 6. All the real values from 1 to 6. We can create such random variable, right? Definitely. So it can be any random experiment. So let's not get into more examples because that will consume time. So I'm taking one random variable which is a continuous random variable. How do we get a continuous random variable? From a continuous sample space, something like temperature. Temperature if you take, so generally the temperature in a day will be, it can take any value from 20 to 35 or 20 to 40 based on the location. So 20 to 40, what temperature will it take? It will take only certain temperatures, or all the temperatures are possible? All the temperatures are possible. So which means it is a continuous sample space. If you map those temperatures to a random variable, so that will be continuous random variable. So since x takes continuous values, let me assume that x is taking only values from 1 to 6 with a certain probability. So can any what will be the height? Because this is PDF, probability density function. If you add up all the probabilities, the result should be 1. But here, since there are too many values to add, you can't do addition. We have to do only integration. So if you do integrate, which means like area. So if you do area of this total all the probabilities, if you integrate all the probabilities here, so the total probability should be equal to 1, we know, because total probability can never exceed 1. It should be equal to 1. Total probability can never be less than 1 also. It should be always equal to 1. So what should be the height? So that the area will be 1, or the total probability will be 1. It is 1 by 5. Correct? Now comes the interesting part. Can anyone tell me what is the functional value in this at x equal to 2? Anyone? Can anyone tell me what is the functional value? What is the value taken by the function at x equal to 2? Anybody? Wonderful, Deepak. It is 1 by 5. Similarly, can you tell me what is the functional value taken in the previous example at x equal to 2? Come on. That is 1 by 6, correct? Right. Now let me change the question a little bit. Let me ask you in a different manner. This is a function, okay, which contains the information of probabilities. This consists of information of probabilities. I'm asking you, what is the probability? P means I'm talking about probability that x takes a value 2. What is the probability that x takes a value 2? Anyone? Here, probability that x takes a value is 1 by 6, very clear. Probability that x equal to 2 or function value, both are same. Which means in discrete case, whatever is shown up here, whatever are the function values, they are nothing but probabilities at those points. Is it the same case in continuous also? Let's see. Can you tell me what is the probability that here? What is the probability that x takes a value 2? Can you tell me? Can anyone tell me? You might say 1 by 5. Is it correct? If it is 1 by 5, assuming 1 by 5, most of you will say the answer is 1 by 5. Function value is 1 by 5. Probability, is it 1 by 5 or not? We have to see. When I say probability that x takes a value 2 is 1 by 5 means the probability that x takes a value 2 is 1 by 5. Is that correct or not? If it is 1 by 5, then try to understand what is the probability that x takes value 2.1, 2.2, 2.3. All of that also will be 1 by 5, no? If you add up all those probabilities, 1 by 5 for 1, 1 by 5, 1.1, 1.2, 1.3, if you add up, it will become infinity, no? But total probability can never be infinity. If the probability of taking a value 2 is 1 by 5, probability of remaining values is also 1 by 5. If you add up all those 1 by 5s infinite times, it will become infinity. But sum of total probabilities can never be infinity. It should be only equal to 1, which means our answer is wrong. 1 by 5 is wrong. But sir, but 1 by 5 is appearing here. Yes, 1 by 5. This is functional value, probability density function value, which consists of information of probability. But whatever is appearing, that need not give you direct probability, but that has information of probability. That will not give you the exact probability value in continuous case. In discrete case, there is no confusion. Only in continuous case, there is a confusion. So you have to be careful here. So what is the probability here? Whenever you want to find the probability at a point in continuous PDF or in discrete PDF also, you can do the same procedure. If you want to find the probability at x equal to 2, try to do it like this. Can I say it as 2 minus less than x less than 2? Can we understand it like this? 2 minus 2. You can say it as 2 minus 2, 2. 2 minus 2, 2 plus. Sorry. 2 minus means a value just before 2. 2 plus means a value just after 2. Right. So here also you can apply the same funda. 2 minus less than x less than 2 plus. In continuous case or discrete case, whenever they are asking probability at a point, try to understand it at a point as a range. Then it will be very clear. So from 2 minus to 2 plus, whatever are the probabilities, just add them up. It will be 1 by 6 here, no confusion here. Okay, here we can avoid the confusion by writing in this way. So 2 minus, this is 2 minus and this is 2 plus. From 2 minus to 2 plus, they add up all the probabilities. Since it is continuous, you can't add up. You have to integrate, which means the area. This area, if you find out, that will give you the probability at 2. It's not the height at 2, it's the area at 2 that matters. Whenever you want to find the probability at a point from continuous PDF or discrete PDF also, you should find the area. In discrete case, we don't find areas, so that's that value that is appearing here, that itself will be the probability. In continuous case, since it is continuous, you should find the area at that point. Area at that point means from the point before that to after that. So what is the area here? Height is 1 by 5, we know that. Look at it as a rectangle. Height is 1 by 5 and width is 0. 1 by 5 into 0. It's not 0 actually. Width is not exactly 0. It's very small value. So 1 by 5 into infinitesimally small value will become infinitesimally small value. So the answer here is that this area is infinitely small. Infinitely small. That is the perfect answer to say. Infinitesimally small. But if that option is not there in that answer is not there in the options, then you can go with 0 because it's very small value, almost close to 0. But is it exactly 0? No. Because if you say this is 0, the probability 2.1 is also 0, 2.2 is also 0. At all points if it is 0, 0 plus 0 plus 0, total probability will become 0, which is also not correct. Here the probability is very small, so small that sum of all these small probabilities will result in 1. Okay, so basically the answer is infinitesimally small, very small. That is the perfect answer. But if that generally that option will not be available for us, so that's why we will go with 0. Probability at a particular point will be 0 generally in continuous PDFs. Not always. Not always. I'll give you some examples. I'll give you one more example. Okay. Zero to 4, and this is 6. Random variable y, and I'm giving you the PDF of y. So can anyone tell me? Let me write here 1 by. If this is small a, let me ask you a question here. Let me ask you like a question here. So first question is, I'm asking you to find what is a. Come on, you can answer now. You use all your understanding to tell me the answers. What is a value here? Because I told you that this function is a PDF function. The information that I'm giving you is fy of y is a PDF, where y is a random variable. I'm asking you what is a. Anyone? Ananya? So that is a topic for some other day. Okay. So this is a revision session. It's running very tightly, so I can't deviate from the topic. Excuse me for that. Okay. So what is a value? Come on. So a value is, come on, it's an easy thing, no? It's a PDF, right? If it is a PDF, then what? Area should be 1, no? Area should be equal to 1, no? So if area should be 1, can you tell me what is the area of this one? It is 4a plus, what is the area of this part of the function? It is half, right? Whatever is written on the impulse, continuous impulse, that itself is the area of the impulse, right? So area of this part is half, and area of this part is 4a because it is looking like a rectangle. The total area of this total function is 1. So it is 4a is equal to half onto this side, it becomes half, and a equal to 1 by 8. Okay, very good. I'll be happy if you can be more faster, because this is an easy question, right? Come on, next one. I'll ask you one more question. Let's see how fast you'll answer. From the same diagram, I'll ask you some questions. Could you tell me what is the probability that y takes a value 2.7? Probability that y takes a value 2.7? Anyone? Very good, Deepak. It is a value only, no? At 2.7. Come on, Deepak. I don't think it is right answer, sir. At 2.7, the height, the function value is a, which is 1 by 8. Function value is 1 by 8, but what is the probability? When I told you, whenever they are talking about a probability at a point, write it like this. From the point before that to after that. Y less than 2.7 plus. So what is the area from 2.7 minus to 2.7 plus? Infinitesimally small. Infinitesimally small, which is approximately almost 0. Not exactly 0, but almost 0. I'm talking about probability at 2.7. I'm not talking about the function value. Nobody asks you the function value, okay, generally. People will be interested in probability value. Okay, so in continuous PDFs, the information shown is not the probability value exactly. It's but that consists of information of probability. It has information of probability, correct or not? If you want to find this small area, you need the height, no? Without height, how can you find the probability? Or how can you find the area? So that has probability information, but whatever is you're seeing here, that is not probability. That is function, PDF function's value. But that will have internally the probability information. Right, I'll ask you one more question. Let's see how you'll answer. Fy of y equal to 5. Come on, make it fast. What is the function value at 5? It's a very easy question. Function value at 5, you can clearly see that it is 0. And how about probability at y equal to 6? Anyone? Probability at y equal to 6. Probability at y equal to 6. Anyone? See, at y equal to 6 means you should try to understand it as 6 minus. Always try to understand it like this. 6 minus less than y less than 6 plus. Don't worry if I'm using small letter or capital letter. That should not make any difference in calculations. Okay, you are saying the previous answer. Okay, that's fine. 6 minus to 6 plus, which means since it is continuous, you just try to find the area from 6 minus to 6 plus. Add up all the probabilities from 6 minus to 6 plus. How do you add up? Since it is continuous function, you should do integration. How do you add up continuous values? By integration only, right? Integration from 6 minus to 6 plus. Add up all the values from 6 minus to 6 plus. What is the probability density? What is the function here? It is, can I write this as 1 by 2 is the area. That's why I'm writing it as 1 by 2 into del of y minus 6. Is that okay? You can write it like that, 1 by 2 into del of y minus 6. I'm trying to do it mathematically also, but just by looking at it, you can say the answer. 1 by 2 outside, area of impulses in this region, area of impulse is 1, so it is half. Or whatever is the area of the impulse, that is what is appearing here. Whatever is written beside continuous impulse, that itself is the area of the impulse. And here we are trying to find the area of the impulse. Right, whatever is appearing here is the probability information only. Okay, so probability at a point, you might think that probability at a point will always be 0. No. In some cases like this, where there are impulses, it need not be 0. If there is an impulse, the area at a particular point is generally 0. But if there is an impulse at that point, it need not be 0. Right? So here, since the area at this point is half, the probability also will be half for y equal to 6. Now let me ask you something. What is the function value at y equal to 6? Anyone? What is the function value at y equal to 6? Anyone can answer this? Then I would say you are really, really good. Anyone? What is the function value? What is the value taken here? What is the value taken here? It is, what is height? What is the height here? Height of an impulse is always infinity, right? What is the height of impulse, Mohammed? Infinity, no? I'm asking you this function. What value is this function taking at 6? It is taking a height of infinity with an area of half. Okay, very good. So I hope you are clear with PDF. One tricky part that they can talk about is with the presence of impulses. With the presence of impulses. Right, I'm moving on to the next slide. Okay, so let's see. I'll give you one more quick question, but I'll be quick in answering them. I want you to be faster than me. Height here is what I'm writing beside the impulse is b, and here also I'm writing b, and the height here is okay. That is the question. Come on, let's see how good you are. I'm asking you, the first question is, what is b? I've given you PDF of z. I'm taking random variable as z. I want you to get used to different notations, so that's why I'm taking different letters for random variables. Second question. By the time I write the second question, I want the answer for the first question. Second question is, what is the probability that z is the random variable here? I should not talk in terms of x. What is the probability that z takes a value 1? What is the probability that z takes a value between 4 and 7? Question D. What is the probability that z takes a value 1 less than z less than 5? Anyone answers for the first question at least? Okay. Probability of z less than 3. Probability of z greater than 6. Rishika, 4/5 for the first question. Are you talking about B? It can't be such a big value. Very good. 1/4 should be correct answer. See this one. Simple funda is integration of fz of z or area of the PDF. This is PDF, right? I told you that z is a random variable and this is a PDF function. Whenever I say PDF, one simple property is total probability should be 1. In the properties of probabilities, we have talked about that. Total probability should be 1. If it is continuous PDF, how do you find the total probability? You should add up all the probabilities, right? How do you add them up? by doing integration, right? So by doing integration you can get the total probability, which should end up at 1. Okay, now so what is the total area? Just find the total area. Since these are simple signals, you can find the total area very easily. What is the area of this impulse? B. What is the area of this impulse? B. B plus B is 2B is the total area of the impulses. And how about the rectangles? This rectangle is area is 2 is the width and height is 1 by 10. 2 into 1 by 10. 2 into 1 by 10 plus what is the area of this rectangle? Width is 4 to 7 is 3. Width is 3. Height is 1 by 10, which is 3 into 1 by 10. This total result should be equal to 1, right? So 2B is equal to this 2 by 10 plus 3 by 10 is 5 by 10. 5 by 10 is nothing but 1 by 2. If it goes on to the other side, it becomes 1 minus 1 by 2 is 1 by 2. So B becomes 1 by 4. It's an answer. Just by looking at it, we can say the answer. Okay, right. So answer for B is 1 by 4. I hope everybody understood. Simple funda. Area of PDF is 1. Many problems were asked in the previous year papers based on the simple property. Let them give any shape. Generally, they'll give in the exam, since it is a time-bound exam, they'll give a shape for which finding area will be easy. They'll not give some shapes for which you can't find the area. Very easy shapes like rectangles, triangles, kind of shapes they'll give us. Simply, you should use some basic math. Right? How about probability of z equal to 1? Anyone? Probability of z equal to 1 is nothing but, always try to understand this way. Z equal to 1 means whenever they're asking us probability at one point, try to find the probability, try to understand the probability at a point as probability in the range. 1 minus 2 1 plus probability is same as z equal to 1 probability, right? That 1 minus 2 1 plus means find the area from 1 minus 2 1 plus. What is the area? Whatever is written on the impulse, that itself is the area, which is B. And we know what is B, which is 1 by 4. Next, from 4 to 7, what is the probability? So try to understand the meaning of this. What are the values of z I'm interested in? 4 to 7. What are the values of z that we are interested in? 4 to 7. For all those values of z from 4 to 7, we are interested in the probability of all those values. From 4 to 7, all values probabilities I want it. So see the probability at 4. Individually probability at 4, 5, 6, 7 will be almost 0. But we are wanting the probability from all the values from 4 to 7. 4 to 7, how many values are there? Infinite values are there. All those probabilities we have to add it up. So since there are continuous values, how do you add it? By doing integration. So what we have to integrate? We have to integrate this function. We want to integrate this probability density function from 4 to 7. So you just need to find the area from 4 to 7 of fz of z dz, which is equal to, what is the area from 4 to 7? You can find the area directly. Width is 3, height is 1 by 10, which is 3 by 10. My mistake. So if you find the area of this function, it's not only the rectangle part but the impulse also is there. It is 3 by 10 plus B. What is B? 1 by 4. 3 by 10 plus 1 by 4. 3 by 10 plus 1 by 4. What is the answer? It is 3 to the 6 plus 2. 8 by 20. What is 12 plus 10? 22 by 40, which is 11 by 20. Perfect. Very good. Many of you answered correctly. Very good. So sometimes the mistake that we might be doing is finding the area from 4 to 7. We might forget this impulse area, but we have to consider that also. Because when you are integrating, this total function we are integrating, not just the rectangle part. Very good. So how about 1 to 5? 1 to 5. This question, if you can answer, I think you are very clear with this topic. 1 to 5. I am interested in area from 1 to 5. 1 is not included, mind that. 1 is not included, which means you don't need to include the value of, we are not interested in the value of z equal to 1. We are interested only in the values of z greater than 1. We are interested in the values from here, 1 plus, from 1 plus onwards we are interested. Until what values we are interested? 5 minus. Because we are not interested in the value of 5, which means till just before 5 we are interested. So we are interested in all these values. We are interested in only these range of values. Okay, so should we include the area of these impulses? When you are talking about probability of range of values, we are going to find the area in that region, right? So in the area from here to here, we don't need to include the impulses, correct? Because there is no equal to sign here. Equal to sign is not there, means we don't need to include the probabilities of 1 and 5, which means we don't need to include the impulses here. So find the area from 1 to 5. The area from 1 to 2 is 1 is the width and height is 1 by 10, which is 1 by 10. is this part of the area, and here the area is 0, and here the area is again 1 by 10, which is 2 by 10, which is equal to 1 by 5. Okay, next one, how about probability of z less than 3? Z less than 3, just see what values are we interested in. Just look at the inside part first, don't get confused, it's a very simple thing. Come from inside first. So we are interested in z taking values less than 3, z taking values less than 3, all these values we are interested. What are we interested in? What exactly are we interested in those values? We are interested in the probability of all those values. So add up the probabilities of all those values till 3, from minus infinity till 3, all those values, which means we have to add up the probabilities of all these values. How do we do that? By doing integration, because it is continuous random variable, by doing integration or by finding the area. Okay, if it's not an easy function, you can perform integration operation, but since these are rectangle triangle kind of functions, you can directly find the area using rectangle triangle formulas. So what is the area of this rectangle? It is 1 by 10 into 2, which is 1 by 5 is the area of that rectangle. Since impulse is also included in that range that we are interested in, since z less than 3 means we are interested in z equal to 1 also, z equal to 1 probability also we should include, which is b, or blindly find the area of this total part, which is b is 1 by 4, right? 1 by 5 plus 1 by 4 is 9 by 20. It's wonderful. 9 by 20 is 0.45, right? It's not 0.35, Madhu. Four plus 5 is 9 by 20. 9 by 20 is 0.45. It can't be 0.35. Okay. So quickly tell me the last answer. Z greater than 6 means what? We are interested in z values from 6 to infinity. We are interested in the values of z from 6 till infinity. All these values we are interested in. What exactly are we interested in? We are interested in the probabilities of them. So how do we find how do we add? We are interested in the probabilities of all the values from 6 to infinity. Add up all the probabilities from 6 to infinity. It means finding the area from 6 to infinity. From 6 till infinity, find the total area. What is the area? This part of the area. The remaining part is 0. Only this part is what is important for us. 6 to 7, what is the area? Width is 1, height is 1 by 10. It is 1 by 10. Very good. Okay, I hope it is clear till this point. Can you solve any question based on PDFs? May not be all, but most of the questions you should be able to solve, provided you have understood what I have discussed here. Okay, I'll share the notes. Definitely I'll share the notes in the group, don't worry. Focus on understanding and solving. You don't need to get very fair notes, because understanding, doing and making a fair notes, that's difficult practically. So what is high priority for you, do that properly. Notes part I'll be giving you, don't worry. Okay, right. Now let us quickly, now that we have understood about PDF, let us write properties of PDF. What properties PDF will exhibit? Let's try to we have understood all that. Okay, before discussing properties itself, by applying basic properties of probability, just by having simple understanding of probability only, we have done the previous two problems, right? Okay, what are the properties that are exhibited by PDF? The same properties that are exhibited by the probability itself. Whatever properties are exhibited by probability, same properties, but we might write in a different format, but same properties are exhibited by PDF also. Why same properties? Because probability and probability density function, they're talking about the same things, right? PDF means what? It's a function of probabilities, right? It is also a function which consists of probabilities only. So properties of probability will carry forward to properties of PDF also, right? So if you remember, right, So for a discrete case, I'll write the properties of PDF differently for a discrete case and continuous case. Okay, for a discrete and continuous, I'll write it differently. Slight difference. Okay, slight difference only for once. Can anyone tell me what is the first property of probability? Probability, first property is probability of any event will be in the range of 0 to 1. Correct? Same funda here also. If x is discrete random variable, if x is a discrete random variable, then what? Fx of x. Generally, this notation they generally don't use in discrete case, but anyway, my intention is not to worry about the notation. They can use any notation they want. If this is the PDF of a discrete random variable x, which means x takes only discrete values with non-zero probabilities, which means countable number of values, like die experiment case. So what are the range of values taken by the PDF? Same range, 0 to 1 only, correct? Ram, I'm not. How can I teach engineering, man? If I'm a doctor. So yeah, I'll try to write more in a better manner. Okay, since this is my first class, I don't know. I'm not focusing on my handwriting. I'll try to write in a better manner. Okay, right. If x is a continuous random variable, then can you tell me the range of values that the probability density function will take? Here, probability density function, whatever values in discrete case, whatever values PDF function shows, those are PDF probability values. The probability values and function values are same in discrete case, in discrete random variables. Whereas in continuous random variables, we have seen examples in the previous slides, right? So whereas in continuous case, the function values are different from probabilities. Function values will consist of information of probability, but whatever values we see, they are not probabilities, right? They are not probabilities. So can anyone tell me what is the range here? Range is function values will always be greater than or equal to 0. We can't say that it is less than or equal to 1. Generally, it will be less than 1, but not all cases. I'll give you some example. Okay, understand it carefully. I'll rub it because I have to write the properties in this slide. Let's say there is a random variable x which takes values from 0 to 1 by 4. Could you tell me what is the height? Could you tell me what is the height so that the area will be 1? Should the height be 4 or not? Should the height be 4 or not? Right? If the height is 4, then only the area will be 1. Right? So the area will be 1. So, sir, 4 is the probability 4 possible. See, this 4 is not probability, okay? This 4 is the function value. So now try to understand this. What is probability that x equal to 1 by 8? What is the probability that x equal to 1 by 8? It is not 4, no, it is not 4. It is only the function value. You have to find the area here. At 1 by 8, you have to find the area, which is very, very small. 4 multiplied with very small value will become almost 0. So here the probability, so though the height is more than 1, the probability is never more than 1. Okay, but the function value can be more than 1 or not. Function value can definitely, sometimes it can be more than 1 also. Will it be less than 1 also? Yes, it can be less than 1 also. I'll take one more example. 0 to 4 or 0 to 8. What is the height? It will be 1 by 8. No? The height can be less than 1. Height will be greater than 1 also. In discrete case, it will be always less than 1. Function value and probabilities are same, so it should be always less than 1. In continuous case, function values and probabilities are different. So that's why it need not be less than 1. Height can be more than 1 also. But the only thing that we can guarantee about PDF is it is always non-negative. PDF function will never take negative values because probability can never be negative. Whether it is discrete function or a continuous function, it will always be non-negative. I'm not saying positive because probability can be 0 also, right? It can be positive or it can be 0, which I'm calling it as non-negative. Okay, wonderful. So how about the second property? Only 2 properties we have. Second property, sum of all probabilities will be equal to 1. No? So if you do, since this is a discrete function Discrete function, if you want to add up all the probabilities, you just need to do summation, right? For what values of x you should do summation? For all values from minus infinity to plus infinity. For all values of x from minus infinity to plus infinity, if you just add up the probabilities, that should result in 1. If it is not resulting in 1, it is not a PDF function. It can be a function, but if it is a PDF function, it should satisfy these two properties. If it is a discrete random variables PDF, it should satisfy these two properties. And how about continuous PDF? Continuous probability density function. The total probability, second property of probability is sum of probabilities of all possible outcomes is equal to 1. So all possibilities are mapped to what? They are mapped onto different values of random variable. Correct or not? What is the definition of random variable? Sample space outcomes are mapped onto random variable values. Right? Sum of probabilities of all outcomes of sample space means sum of probabilities of all values of random variable. If it is continuous, it means you just need to add up all the probabilities. How do you add up for continuous case? Because there are infinite values to add up. Minus infinity to plus infinity. I'm integrating this function. Why am I integrating? Because I'm trying to add up all the probabilities from minus infinity to plus infinity. So dx. I'm integrating with respect to the random variable itself. That should result in what? 1. Beautiful property, wonderful property, based on which lots of questions can be framed. This is the most important property based on which a lot of questions were asked in the previous papers. Okay, beautiful, wonderful property. These are the two properties. Question will be based on this property or this property for a discrete case. You just need to apply this property carefully. Okay, right. So apart from properties, let us discuss few things. Okay, apart from properties, let us whatever we have done in the previous problems, only those things I just want to write it down. Instead of properties, we can write them as observations or okay. So if you want to find out the probability from 2 less than x less than 6, how do you write it? How do you find that? You are interested in the values of x from 2 to 6. Since you are talking about continuous random variable, you just need to add up the probabilities from 2 to 6. How do you do that? Take this PDF. You just need to find the area from 2 to 6. How do you find the area? By integration from 2 to 6 dx. Is that okay? So are we interested in 2? Are we interested in 2? No, right? We are not interested. So 2 is not, we are not interested. Basically, you can write it as 2 to 6, not a problem. But if you want to write it more appropriately, we are not interested in 2. We are interested in values after 2. So that's why I'm writing it as 2 plus. This is more appropriate, you can say. But there is nothing wrong in writing it as 2 to 6. But 2 plus is more appropriate. Because we are not interested in 2, right? Because there is no equal to sign. And we are also not interested in 6. We are also not interested in 6. We are also not interested in 6. So which means we are interested in values up to 6, which is like 6 minus. 6 minus. Okay. Okay, how about this one? X less than or equal to 4. How about this one? We are interested in the values of x from minus infinity to 4. Minus infinity to 4. Since 4 is also included here, you can leave it as 4. So like this, any range of x values, you just need to integrate in that range. Okay. Very good. Now similarly, let us talk about cumulative distribution function. This is again one more wonderful function based on which beautiful questions can be framed. So the notation generally for this kind of functions will be something like this. They use generally capital letters. That does not mean that PDF they can't use capital letters. They can use capital letters there also. So how will we know, sir? Will there not be any confusion? There will not be any confusion because they will clearly tell you. They will clearly tell you whether it is PDF or CDF. Or even if they don't tell you also, we know the properties, right? Based on the properties, you can definitely understand. Generally, questions will be framed in a very clear manner. You will not have any confusion, irrespective of the notations they take. So generally, capital F is the letter they will use, or capital G, capital, some capital letters they'll use generally. Or sometimes they also take it as just capital F of X. Or sometimes they also take it as capital P of X. Any notation will go. Properties will remain the same. The understanding will remain the same. Right. So what is CDF? CDF is also function, right? They themselves are saying no cumulative distribution function. So CDF, what is the domain? What is the domain? Random variable. Random variable is the domain. And what is the range? It's not probabilities. In PDF it was probabilities, right? Now here it is cumulative probabilities. Cumulative probabilities. Cumulative probabilities. Okay, wonderful. CDF is a function where the domain is random variable and range is cumulative probabilities. Okay, right. So let me define this cumulative distribution function. If the notation is like this, what is the meaning of this? What is the meaning of this? If I'm writing something like this, the meaning of it is P of X less than or equal to X naught. When you're talking about PDF, it is showing us the probability information only at that particular point. Whereas CDF is not showing the probability at that particular point, at that particular value, but it is showing the probabilities till that value. Okay, if it was probability density function, we are interested in the value, only the probability of X naught. Whereas in CDF, we are interested in the probabilities till X naught. From where? From minus infinity. From minus infinity till X naught, all the probability, accumulated probability, added probability we are interested. So which also can be written as P of minus infinity less than random variable X less than or equal to X naught. This is the meaning of the CDF. So in CDF function, if I'm talking about fx of 1, which means CDF value at 1 means what does it represent? I'm interested in all the probabilities till 1. This function's value at 1, whatever this function is showing at 1, whatever is the height shown at 1, that is the accumulated probabilities of random variable X from minus infinity to 1. There's nothing but minus infinity till 1, accumulate all the probabilities. That is the value of the function shown at 1. So this we can, how do you find it? We know this string, right? So you just need to add up all the probabilities from minus infinity to 1 using the probability density function. Okay. So using this, we can write a relation between PDF and CDF, right? How do we write it? Fx of X naught can be written as, see this one? We are interested in the probabilities from minus infinity to X naught. Minus infinity to X naught, the PDF. Take the PDF and integrate it from minus infinity to X naught, which means we are accumulating all the probabilities from minus infinity to X naught. If we accumulate, you'll get the function, CDF function value at X naught. So whatever is the value here, the same value will be here in the upper limit. Okay, instead of X, I have taken X naught just to show you that this the value here and the value here in the upper limit should be same. If I take X here, you'll be confused. Here X, here X, here also X. There will be confusion. So just to avoid confusion, I have taken X naught here just to show that these two values are same. Okay. So could you tell me the reverse relation also? Can you find PDF from CDF? Since this is integration, the reverse will be differentiation. So if we differentiate the CDF, you'll get the PDF. Simple relation. Yes, here it is equal to 1. Yeah, I missed, Madhu. Thank you. So this is the basic understanding of cumulative distribution function. So if the understanding is not clear, there is a lot to observe here. So just try to understand the meaning of this. Once you understand the meaning of this function, what is the meaning of this clearly, then you can do any problem based on CDF. The information in PDF and CDF is same, but the presentation is different. In PDF, individual probabilities are present, whereas in CDF, accumulated probabilities are present. Okay, so I generally give an example of semester marks, right? First semester, you got some marks, or you got some GPA, grade point average. Okay, that is like a probability. Second semester grade point average, that is like a probability at that semester. GPA at that semester, GPA at the next semester, GPA at the next semester. After the first semester, CGPA and GPA both will be same. After the second semester, CGPA is different, GPA is different, right? Because it is a accumulated version of first semester and second semester. Till the third semester result happens, CGPA will be same because there is no extra result. After third semester till the fourth semester result, CGPA will be remaining same, right? Because there is nothing to accumulate between third semester and fourth semester, or fourth semester to fifth semester. Similarly, cumulative distribution function will be remaining constant if there is no probability to accumulate in between. Okay, I hope you're following. Vicky, I think so. I'll be teaching maybe. We'll get the clarity soon. Okay, I've just now started working here, so soon I'll know when I'll be starting my communications batch and signals batch. No, yeah. So this session is not for electrical branch. Okay, electrical students, you can take, you can work on something else. This is not for you. This session is exclusively for ECE students because this topic is not available for you. Okay, so if you want to avoid distractions, you'll not have distractions if you're serious about your work. If you're really serious about your goals, then nothing will distract you. If things are easily distracting you, means you are not really serious about your goals. Okay, check yourself. When you are not really serious, but you are feeling that you are serious, then what happens? Everything will distract you. But if when your highest priority is whatever you are working on, then nothing can distract you. Even if some thunder happens beside you, also you'll feel that okay, thunder happened. I'll let me keep working. What will that do to me? So your thought process will be in that manner. Okay. So we've talked about CDF, and we have understood the relation between PDF and CDF also. Okay. So I've gone little briefly regarding CDF. So we'll do some problems. I think you are distracting me now. Okay, fine. So let me ask you some questions here. Could you find for this function, for this PDF, can you find the CDF? Can you find the CDF for this? Can you find the CDF for this? Can you find the CDF for those two functions? For this function and for this function. 0 to 4 and at 6. This is fy of y. Okay, so let's find capital Fy of y. Let's find capital Fy of y. You can do in any manner that you know. You can do in any mathematical procedure that you know. If you know how to integrate, you can do in any manner. Before going further, I want to ask you one more thing. How about probability of x naught less than x less than or equal to x1? How about this range of probabilities? How about that? We know the meaning of this. We are interested in the values from x0 to x1, x0 to x1. So find the area of the PDF from x0 to x1. But are we interested in x0? No, right? So that's why let us start in being interested in values from x0 plus to x1. Because we are not, there is no equal to sign here. Since we are not interested in x1, we are interested in the values after x1. So start from x0 plus. Okay. So can I write it as x0 plus? Okay. Okay. So we can write like this, or we can also, can we also write it as p of x less than or equal to x1 minus p of x less than or equal to x0. See this one? Is this fine or not? Here we are interested in the values from minus infinity to x1, x1 included. Here we are interested in the values from minus infinity to x0, x0 included. Now if you subtract the probabilities, you are subtracting the probabilities from minus infinity to x0. See, minus infinity to x0 till x1. Here you're talking about the probabilities of these values. Here you're talking about the probabilities of these values. So when you subtract these two, you will be interested only in these values, right? So x till x0 you're subtracting, no? X0 also you're subtracting. So what will remain is x0 plus till x1. I hope you're following. Did you understand this step? When I'm interested in the values from x0 to x1, you can write it as, you can find this easily by using Cdf. Finding the area from minus infinity to x1, we can do it. Finding the area from minus infinity to x0, we can do it. If you subtract these two, then what we get is, we get this thing. Okay, right. So why I'm talking about this is because by expressing in this manner, we can also express it as, it is looking like CDF, the CDF function at x1 value, and this is also looking like CDF function at x0 location. CDF function at x0. So whenever they are asking about the probability of a range of values, then you can always write it as subtraction of CDFs, something like this. Okay, right. So I'll ask you little variations of this x0. Actually, the variations are not required for you to remember, but just to test your understanding, I'll ask you a few things. How about this one? Small change, no? And the answer also will be a small change, right? But don't try to remember. If you remember, you'll definitely forget. If you understand, you'll not forget. Try to tell me this. So I'm interested in values of x0 here. Here I was not interested in values of x0. So that's why I'm taking the value of x0 here, I'm subtracting it. But here, since I'm interested in x0 value, I should not subtract the probability of x0, which means I should not include x0 here, which means I'm taking till x0 minus. If I'm taking till x0 minus, I'm not subtracting the probability at x0. Okay, like that, if there is equal to or not, you can easily understand things. So you can play around with this, with no equal to in both places, and equal to here and no equal to here, and try to write the answers. Okay, you can post it in the comments after this live discussion is over. You can post it in the comments if you have answered correctly. If you have doubts, you can post it in our group also, Telegram group also, so we can help you with that. Okay, So I'm moving on to the question that I've asked you previously. The question that I've asked you is, for this fy of y function, could you tell me the CDF? CDF is what? Integration. Minus infinity to whatever is the value here, that is the upper limit. Small fy of y dy is simply integration. It's simply integration. Whatever you might be very good at integration because you are studying for GATE. You might be very good at math, so you can do it integration very easily. So I also used to teach this part of integration in my signals course. So but here, since this is revision session, I'm not going to do integration. So what is integration of this one? Constant signal integration will be linearly increasing, something like this. And till 4 it is constant. It's like 1 by 8. 1 by 8 integration is 1 by 8x, right? 1 by 8x. And at 4, what is integrated value? 1 by 8x. If you substitute 4, it will be 1 by 2. The height here will be 1 by 2. And integrated signal after 4, there is nothing to accumulate. Integration is also like accumulation, adding up the area. So there is nothing to accumulate. When there is nothing to accumulate, it will stay constant. Or it is like CDF means accumulation of probabilities. If you want at 1, till 1, you add up the area, accumulate the area, or add up the probabilities till 1 and write the value here. At 1, the value. Can anyone guess what is the value at 1? Whatever is the area till 1, that will be the height at 1. CDF at 1 will give us the accumulation of probabilities till 1. The accumulation of probabilities till 1 is 1 by 8, so the height here also will be 1 by 8. Could you tell me what is the value at 2? CDF value at 2 is nothing but accumulation of probabilities till 2. Accumulation of probabilities till 2. Adding up the probabilities till 2, what will it give us? 2 times 1 by 8 is 1 by 4. So it will give us 1 by 4 here. Similarly at 3 also we can do. The CDF function value at 3 is nothing but the accumulation of probabilities till 3. Accumulation of probabilities till 3. So add up the probabilities till 3, which means area till 3, just 3 by 8. This is 3 by 8. Similarly at 4. Next, at 5, could you tell me what is the CDF value? At 5 means area till 5. Area till 5 means area till 4 and area from 4 to 5 also. From 4 to 5 there is no area. Whatever is the area till 4, that itself will be the area till 5. That itself will be the area till 6 minus also. Right? So same area till 4 or till 5 or till 6, which means CDF function value at 4, at 5 or any value between 4 to 6 will be same because there is no probability to accumulate from 4 to 6. CDF means accumulation of probabilities. No, as you travel in this direction, you're going to accumulate whatever probabilities are coming your way. There is nothing to accumulate here, so CDF function will stay constant. So point to remember is, whenever the CDF is constant, which means in that region there is no probability to accumulate. There is no probability to accumulate means in PDF function it should be 0 value. It should be consisting of a 0 value. Okay, right. Next, at 6 what is happening? At 6 what is happening? There is something to accumulate. There is something significant to accumulate. So if you observe from 0 to 4, we are accumulating, but we are accumulating small values. At every point we are accumulating small values, infinitesimally small probabilities, right? At 2, very small probability. At 3, very small probability. So that's why it is increasing slowly. But at 6, suddenly there is an accumulation of half probability. From 6 minus to 6 plus, suddenly there is an accumulation of half. So there is an accumulation of half. So CDF will increase by half. And after that there is nothing to accumulate, so it will stay constant. So without any mathematical integration also, by common sense also you can do this. But not always common sense will work. If they give us complicated questions with complicated equations, then it is difficult to do using common sense procedure. But generally in GATE exam, since it is a time-bound exam, generally they will give us questions. Most of the questions can be done out of common sense with basic understanding of the concepts. Right? What is the height here? 1. So one more thing to remember is the value of CDF function will be 1 at some future value, because some CDF is nothing but sum of probabilities. No, sum of probabilities till a certain point, but sum of all probabilities, sum of all possibilities will be equal to 1. So that's why after some value of random variable, maybe 6, some other random 10, some other random 1000, some other random at infinity at least, at some future values of a random variable, it will be equal to 1, and from that point onwards it will be equal to 1. See this one. After certain point onwards, it will be constant. It can never be greater than 1. Okay, let me write that point here. I did not write the point here. Yes, CDF. Regarding CDF, okay, we did not write the properties of CDF. Anyway, we'll write them down. First, let us do the problem. Once we do the problem, we'll get clarity on what properties it is exhibiting. Okay, so I hope this is clear. If this is clear, can you do the same question, second 2, 3, 4, 5 using CDF? Can you do it? Can you do it using CDF? Can you or not? Using CDF, whatever problems you have done using PDF, you can do it also using CDF. This problem I'll do. Next question you can try yourself. Okay. The second question that you have done previously. Question is P of y equal to 2.7. P of y equal to 2.7. This is what we are interested in. So try to write it as a range. Okay. 2.7 minus less than y less than 2.7 plus, which also can be written as, it is looking like P of x naught less than x less than x1. We're talking about range of probabilities. You can write it as fx of x1 minus fx of x naught, something like that. 2.7 plus, but there is no equal to here. There is no, if there is equal to, then only we'll write 2.7. Otherwise, you can write it as just 2.7 minus fx of 2.7 minus. Okay, if there are no impulses, you don't need to worry about whether there is an equal to or not. If there are impulses, then only you have to be careful. So how about fx of 2.7? 2.7 minus and 2.7 plus, both values are same, no? So if you subtract, you will get 0, no? So CDF, using CDF also, you can do every problem. Every problem that you can do using PDF, you can do using CDF also. Similarly, can you do the third question also? Function value. If you want to find the function value, you have to do differentiation. There is no other way. Third one, fy of y equal to 5. Okay, fy of y equal to 5. See, if you see, there is a constant function here. Constant function means if you differentiate, what happens? It becomes 0. Differentiation in the at f5, since slope is 0, it should become 0. Like that, using CDF, we can do every problem. P of y equal to 6, same procedure. P of y equal to 6. So we can also write as P of 6 minus less than x less than y less than 6 plus, which can be written as fy of 6 minus fy of fy of 6 plus minus fy of 6 minus, which is, what is fy 6 plus? 6 at 6 plus the value is 1, and at 6 minus the value is half. The result will become 1 minus half is half. Okay, similarly you can do the next question also. Fy of y equal to 6. Fy of y equal to 6 means it's the differentiation. Okay, it's the differentiation. Whenever you want function value from CDF function, you can get the PDF function by differentiation. If you differentiate this function at 6, there is a discontinuity. Whenever there is a discontinuity, the slope will become infinity. Whenever there is a discontinuity, the observation is, whenever there is a discontinuity here, it is because of impulse in PDF. Impulse in PDF will be responsible for discontinuity in CDF. So whenever you see discontinuity here, it is because of impulse. So whenever there is a discontinuity, at that point, the probability is significant. It is not infinitesimally small, it is significant value. It's not a very small value, it's a significant value. So discontinuity means there should be an impulse here. Right, so function value. So if you differentiate this function, definitely at discontinuity, the slope or differentiation will be infinity. Okay, as I told you, every question can be solved. Whatever you can solve using PDF, same, all the questions you can solve using CDF also. Using CDF, we can do it actually much faster. Same way, same manner. Everything that I have done here for this question, can you try for this question also? All the questions using CDF. Plot the CDF for this first, and using that CDF function, assume that CDF function is given for you, and these are the questions asked, and try to solve all the questions using CDF function. Okay. I hope everyone is following. Good. Very good. So the topics I wanted to cover, these are the topics: probability density function, cumulative density function, and problems based on PDF and CDF. So I've covered few problems based on PDF and CDF. The understanding in those problems is sufficient enough to do any problem on PDF and CDF, provided you have understood things correctly. So if you are finding difficulty in any question based on PDF and CDF, you can post it in our Telegram group. We can help you. Generally, you will not face any difficulty. Okay, so before proceeding to moments, one more thing we should cover. Before proceeding to moments, one more thing is, let us write the properties of CDF. We have written properties of PDF previously. By understanding the problems, we have understood the properties, right? Similarly, let us write the properties of CDF. What properties the CDF function will always exhibit? CDF is nothing but a function. No. A function which exhibits a certain properties, we call it as CDF. A function which exhibits certain properties, we call it as PDF. So what are those properties that are exhibited by CDF function? Could you tell me? CDF function properties are same for a discrete and continuous. For discrete and continuous, both are same, because even for a discrete random variable, also CDF will be continuous. Correct or not? For a discrete random variable, if you plot CDF, it will be some kind of staircase waveform, but still it is continuous only, no? So that's why there is no need to write separate properties for a discrete case and continuous case. You can write it will be same properties for continuous random variable and discrete random variable. Right. So first thing is, could you tell me what are the values taken by the CDF function? CDF function can never take values negative values. It can never take, because CDF is accumulation of probabilities. Probabilities can never be negative, right? If you are accumulating non-negative values, the result also will be non-negative, which means it is greater than or equal to 0. And since it is accumulation of probabilities, how many probabilities you accumulate regarding a single random variable, it can never be greater than 1. So the maximum value possible here is 1. So CDF, whether it is regarding a continuous random variable or a discrete random variable, the values always will be between 0 and 1. Wonderful. The first property. If a function is not satisfying this, if they have given some function and it is taking some value which is greater than 1, it can never be a CDF. Okay, very good. So how about the next property? So second property of PDF. These properties also can get from PDF and probability. Okay, so second property of probability or PDF is sum of all probabilities is equal to 1, right? So how do you signify that? How about this one? Effects of infinity. What is the meaning of this? Effects of infinity means you are interested in all the values of the random variable from minus infinity to plus infinity. You are accumulating all the probabilities till infinity. If you accumulate all the probabilities till infinity, what will be the result? It will be equal to 1, right? Because we know that sum of all probabilities is equal to 1. The second property of probability and PDF has been converted into this form. Okay, so right. So there are many other things that we can write about CDF. Most important thing about CDF is the meaning of it. The meaning of it. Fx of x naught. The meaning of it is probability of x less than or equal to x naught. If you write x here, there should be x here. If you write y here, there should be y here. So the inside value tells us till till what point you are accumulating the probabilities. This is the meaning. So there is a lot of understanding here. So if you understand the meaning of this clearly, CDF will be very easy. Right. So how do we find CDF function from PDF? You know that. Just integrate from minus infinity to this value. Whatever is the value here, that should be here. If it is x naught, here it should be x naught. Integrate the PDF from minus infinity to x. That will give the CDF. The reverse relation is fx of x is equal to differentiation of the CDF. And let me ask you a few more observations. How would fx of minus infinity? fx of minus infinity. So here we're trying to accumulate the probabilities till minus infinity, from minus infinity till minus infinity only. So we're not talking about any values actually. From minus infinity to minus infinity, there is no value of x that you're talking about. From minus infinity to minus infinity, you're not talking about any x value. Okay, so the probabilities of those values from minus infinity to minus infinity is you're like integrating from minus infinity to minus infinity only. So it's like meaning is probability of x less than minus infinity. The meaning of it is like this, which is integration from minus infinity to minus infinity. So the width is 0, almost 0 you're talking about. So it is 0. Fx of plus infinity means you're talking about all the values from minus infinity till plus infinity. Here you're talking about values from minus infinity till minus infinity only. So one more thing I just want to write is probability of x naught less than x. I've written already. I'll write it again. Very important point here. So we can also write this range of probability in a range. We can write it as fx of x1 minus fx of x naught. Very nice. So revision on PDF and CDF is done. We've done some problems also based on PDF and CDF. Right. So before going further, if you want to ask any questions, you can ask me. I hope everyone is doing their preparation seriously. So some of you are asking whether the exam will get postponed or not. If it gets postponed or not, it should not matter for you. If it gets postponed, you'll write a few more mock tests and you'll revise some topics, some more topics. Okay, apart from that, not much difference, right? So based on that, you should not lighten your preparation. So if your seriousness decreases, that should not happen. Be serious. The way you are serious without postponement, the same seriousness you should have if you are having postponement also. You should take it as an opportunity if it happens, and the same opportunity is there for every one of them. So every one of them can revise a bit better. So the competition will increase it definitely. So don't think that things will change because of postponement. So for serious aspirants, it is same whether it is postponement or not. But if it happens on time, that would be better. Surya Prakash, I'm not aware, man. So because this is nobody's clear on what has happened in the last 2 years, right? So because pandemic, when it goes up, when it goes down, we don't know, right? So I'm not an expert on that. I can't predict whether it will get postponed or not. So be prepared for no postponement only. Be prepared for worst, which is like no postponement. Then you can do better job, right? And Ankush, definitely random process we are going to discuss day after tomorrow. 2 days we're going to have. So I'll give some basics on random, some small revision on random process, and I'll cover all the models based on random process. Some more questions, huh? Yes, definitely. Life is not just exam. Exam is part of life, and this exam, GATE exam, is one definitely important destination for us. One challenge that we have taken. So our challenges are not going to get completed by GATE exam, right? Because after GATE exam, your target will be some very big job, a very good job, and after getting into job, your target will be a very good promotion. Uh, After that, you'll have some other target. At any point of time in life, we'll have some target or the other. We'll be working on something or the other. Okay, our mind will never be free. Okay, we'll be targeting something or the other in life. So definitely take it seriously, but don't think that that is the end of life. That if you get we are not able to perform well in gate, that's not end of life. Some other opportunities will show, but you have to put serious efforts. If you're not putting serious efforts in gate, means you'll not be able to put serious efforts in other things also. Okay. Match filters, yes, Ankush, we will. For now, the plan is for the next 4 days is random variables 2 classes and random process 2 classes. After that, based on your sincerity and regularity and your response, we will take up match filters and other topics also. Should I give a practice question? Okay, I'll give you one practice question. Let me tighten the question. I'll complicate the question. What did I give you? Did I give you PDF or CDF? You might have recognized, right? Irrespective of notation. The area of this is infinity. For a PDF area can never be infinity. So definitely we can say that this is not PDF, this should be CDF. So this is 2 by 4, 3 by 4, and this is 1. So first question is question A. This is question number 3. Total I have asked you. The previously 2 diagrams I've given, so that you can think of them as first and second questions. This is the third question. Whenever you are asking a doubt regarding these things in the comments or in the Telegram group, you can address them as 1. And this is 2, second diagram. This is 3. Question A is find PDF first of all on this. You just need to differentiate. If you know how to differentiate, you can find it easily. But common sense also you can say it. You can check the options also. That is also another way. And fx of x equal to 8, p of x equal to 10, p of 2 less than x less than or equal to 8 minus p of 8 minus less than Yeah, I happen to have heard of that student. See, everyone's journey is different, their life story is different. We don't know what they are going through, so sometimes very small thing might appear like a big thing. So yes, even sometimes people who do suicides, at that instant of time they feel so depressed that they wanted to do that. But if they had waited for few more minutes or few more hours, then they would have felt that that situation is not that really important to do such big things, right? They're trying to means doing such extreme things is like escaping from life, not facing them, not facing it. Okay, so I think you have copied the homework. You can take a screenshot if you are a little late. Fine, can I continue? Moments or expectations. Guys, any inputs regarding the speed at which I'm going? The speed, okay. Um, Good. Is it helpful? See, the challenge here will be for me. So, different people will be attending the class with a different expertise. I mean, some people might have prepared very well, some people might have prepared averagely, some people might have spent very less time. So, that's why I'm going at an average, keeping an average student in mind. I'm going. So, if you're a little good, so try to observe more things. If you are a little slow than what I'm teaching, so try to reach up to my speed at least, because I'm targeting only an average student only. Okay, so because I can't cater to every student at every point of time, right? So I hope you can understand my situation. Try to increase your focus and make more observations if you are quick enough, and try to think of what other questions can be framed. Okay, so what are the different ways in which an examiner can ask the questions? So if they ask that way, how can I solve? Something like that. Okay, you can think of in different ways. There is a lot of scope to learn, uh, more than what I'm teaching. If you're willing to learn, there's a lot of scope to learn. Okay, moments or expectations, we also call them as averages. So we find the averages of random things. So specifically we're talking about random variables. So random variable is like a proxy to uh, random things. Okay, so for example, if you perform a die experiment, what outcomes are there, those things we are mapping to some other numbers, and that we are calling it as a random variable. So random variable is like a proxy to some random experiment outcomes. Okay, so if you want to find the expected value of any experiment, something like a bus is coming, at what time it will come, we don't know, because it's random event. So we might ask, what is the expected time of the bus? Nobody can ask what is the exact time that the bus comes. Nobody can tell that. The best question that can we can ask is, what is the expected time that the bus can come? Because nobody knows the exact time. Expected time means the bus need not come at that time, but on an average, the bus might come in and around that time. Okay. So Ram, I think you're more of a philosopher. You have very good philosophy in you, man. I did not have that much of philosophy at your age. Good. Clarity in clarity about life, even as a peon or with a low-paying job, also you can live happily. Without clarity, man, what happens? We'll be running after things. We'll not be happy with even after we achieve a lot of things also. You can't be happy. That people will realize a lot late in the life. Okay, so that's why don't take I can't means I'm not if I pass some statement I should be very clear about it, so that's why I'm thinking carefully before passing any statement. Anyway, let's continue with the topic. So if I get some good statement, I'll pass it on. So my moments are expectations. What are these moments, and what is the importance of them? Expectation means when you're talking about a random outcome, like timing of a bus or timing at which I'll start the class. Actually, my class is scheduled at 5, but because of some technical glitches or whatever, so I'm not able to start at 5. But on expected time for the next 4 days, my expected time is 5 only. But I might start at 2 minutes before, 3 minutes before, or 4 minutes before, 1 minute after, 2 minutes after. We don't know, but the expected time is 5. But if you ask me what exactly is the time that I'm going to start tomorrow, I don't know. Nobody knows, because few seconds this way or that way, it can deviate. Nobody can tell the exact time because it is a random outcome. Time is random thing. Okay, so when you're talking about random things, the best information that can be given is the expected value. The expected value will give us a rough understanding. So if let's say Deepak is asking is asking someone, what is the timing of Dinesh sir class tomorrow? I don't know, man. I don't know when he will start. If he says, then you will not have any idea whether he'll start in the morning or afternoon or evening or what time. There is no idea. But at least he will ask Deepak, what is the expected time, man? Then if he says 5, okay, he'll try to come before half an hour before 5 so that he'll not miss anything. Okay, so expected value will give us some idea. Okay, so expected value will give us some idea, but not a bigger idea. So if you want a better idea, then what should be given is one more thing called variance or standard deviation. Okay, so average timing is 5, expected time is 5, but I might start half an hour before or half an hour after also, 1 hour before, 1 hour after also, or 5 minutes before or 5 minutes after. Let's say Deepak is attending my classes since 1 year. He knows what is my deviation. Generally, I might deviate by 5 minutes maximum, or 10 minutes at max, not more than that. Right? So he'll say, "Sir might deviate by 5 minutes, not more than that." So that will give an idea for the student who is asking the Deepak. Okay, 5 minutes means okay. If I can come 5 minutes before, that should be sufficient. But if Deepak says that 30 minutes is the deviation of sir's class, then he'll be careful that okay, I have to attend half an hour before, so then only I'll not miss anything. So standard deviation is giving us some extra information, right? So this expectation and standard deviation or variance, these things together will give us a better understanding of a random outcome. Be it marks, be it timing, be it any random thing. Everything in our life is random, okay, because random things are difficult to analyze. We don't try to analyze them as random things. We try to define everything in a deterministic manner, but which is not possible. Everything life is random. If we can accept this, if we can accept that, our life will be a lot happier. We are not interested in random things. We want deterministic things. I want these many marks here. I'm not ready to accept less marks. Okay, more marks we are happy, but less marks we are not happy. So we are not ready for uncertain things. We want everything to be certain, which is not possible in life. That's why we'll be unhappy most of the times. Right. So there are two moments that we are interested in random variables. One is mean value, which we represent it as expectation of x. E means expectation of x. We also call it as first order moment. First order moment. So how do you write the definition for this? If it is a discrete random variable, take the variable, multiply it with the PDF, and do the summation. Okay, so this is how we find the average of a random variable, because random variable takes different values from -infinity to +infinity. Each value it takes with different probabilities. Whenever you want to average something, just multiply with the probabilities and add it up. As simple as that. Let's say there are two numbers, 2 and 3. You want to average, what will you do? You'll do this, no? or you can also write it as 2 into 1 by 2 plus 3 into 1 by 2. Average 2 and 3 means we'll do this, which means they are not talking about probability here. But if you're talking about the same thing in terms of probabilities, 2 happens with the probability of half and 3 happens with the probability of half. What are you doing? Whatever numbers you want to average, multiply them with corresponding probabilities and just add it up. Same thing I'm doing here. I'm writing it as a formula. Any number of values of x, do the same thing. Take all the values of x, multiply them with corresponding probabilities and just add it up. You'll get the expectation or movement or average. For if it is a continuous case, if x is this is the formula if x is discrete. We are doing summation only if it is discrete. And how about the integration? If x is continuous, obviously we can't. We have to multiply the values of random variable with probabilities and then add it up. Since there are too many values here, since it is continuous random variable, we can't add it up. We can't do summation. We have to do integration. This is the definition. Right. Next moment is second order moment, we call it, or expectation of x square. So we call it a second order moment. There are different names for this, okay? I'll tell you those names also, don't worry. Many of you might be aware of this. I'm doing a quick revision here. So first tell me, what is the mathematical formula for this? You're trying to, expectation of x square means you're trying to find, expectation means average. What do you want to average? You want to average x square. You want to average x square. Whenever you want to average, what should you do? You should multiply them with corresponding probabilities, right? So x square probability, x square happens with the probability of x only, no? So just multiply x square with probabilities of x only, because x square happens with the same probability as x. So multiply with the probability of x. Okay, whatever is the basic random variable here, you can just multiply with the PDF of that. And then do summation. Minus infinity to plus infinity, if x is discrete. Similarly, if x is continuous, same thing, integration. Minus infinity to plus infinity. Okay. Next. This is, we call it a second order moment. Second order moment. Okay. There is one more moment, you might have heard of it. Expectation of x minus x bar whole square, which we denote it as sigma x square. We also call it as variance. Variance. Notation is like this. Expectation of x minus x bar. From the random variable, remove the DC value or the mean average value. This expected value. Another notation for mean value is like this, x bar. Generally bar on the top means average. So this is equal to, so if you expand this, it will become expectation of, if you expand, it is x square plus x bar square minus 2x into x bar, which is equal to, what is expectation of x square? This one. We can also, there is one more notation for this. We want to average x square, right? So write x square and put a bar on that. That means average. So it is x square bar plus x bar square is a constant. Whenever you apply expectation, there is no randomness. Once you apply expectation, it becomes a deterministic value. Random with x is a random variable. We don't know what value it takes, but when you apply expectation, you're getting some average value, which is a deterministic value, a constant value, you can say. After applying expectation, there is no randomness. Randomness will vanish. Okay. So here x bar square is a constant, right? Because once you apply bar, it's expectation, which will become a constant. Expectation of a constant is definitely a constant. There is no need to expect a constant, right? You're not talking about random variable, then only you should expect something, right? If you're talking about timing, you can expect what is the timing. For a fixed thing, there is no need to do any expectation, right? So expectation of a constant is always a constant, which is the same constant, x bar square. Try to understand the difference. X square bar and x bar square both are different. So 2 x bar outside, expectation will be applied on this x, it will become x bar, which also will become x bar square. So it will become x square bar minus x bar square. So variance is equal to x square bar minus x bar square. Okay, so we can also write it as expectation of this is equal to expectation of x square. We can also write as x square bar is equal to sigma x square plus x bar square. Okay, so first let me tell you what are the other names for this. So we also call this as a DC value sometimes. If you're talking about current or voltage, it makes sense to call it as a DC value. If x is a random variable which represents voltage or current, x bar definitely represents a DC value. So don't call always a DC value, x bar as DC value. It makes sense to call it as DC value only when the random variable represents voltage or current. We also call it as average value also sometimes. First order moment also we can call. So how about this one? We call it as second order moment is one way of calling it, and another most important way of calling it is mean square value. Mean square value or mean of squared value. For the squared random variable, we are trying to find the mean. And whereas this one, x bar whole square, is mean, we are doing whole square. Mean whole square, or we also call it as a DC power. DC value, if you are squaring, you'll get DC power. No, you have learned it in other subjects, right? So whatever we have written in the last slide, I'm just rewriting it again. Expectation of x square is equal to sigma x square plus expectation of x whole square. So we have called it as mean square value. I'll tell you one more way of calling this. There is another name for this. If you're talking about x is a random variable which represents voltage or current, this also can be called as total power. Total power. And this variance. If you're talking about a random variable x as a voltage or current, then we can also call it as AC power. Whenever you see sigma x square, don't call it as AC power. That may not make sense. If the random variable represents voltage or current, then only it will make sense. Okay, wonderful. So this is mean square value, MSV. This is variance, and this is mean whole square. So, or we can also call it as, can we call it as total power or total average? Whenever somebody says total power or total average power, both are same. Total power or total average power. And variance represents AC power. If you're talking about a random variable x as voltage or current, total power is equal to AC power plus this is mean whole square is DC power. Now it will become easy for you to understand. Very simple funda. So this funda you all might have known. I just wanted to quickly recollect these things. Now let us jump into the problems, shall we? Y is equal to bx if y equal to bx. Okay, then can you tell me what is the relation between y bar and x bar? What is the relation? And what is the relation between y square bar and x square bar? What is the relation between sigma y square and sigma x square? Anyone? Come on, make it quick. Similarly, I'm giving you 3 questions I've already given. This is the 4th question I'm talking about. And let's say this is 5th question. So how about y bar and x bar relation? y square bar and x square bar relation, sigma y square and sigma x square relation. When a constant is multiplied to a random variable, what happens to the mean? Wonderful, it's simple, no? First question is very easy. The answer is mean. When you multiply a constant, what happens? The mean value will increase by b times, right? When you multiply a constant, mean value also will increase by b times. Correct? So if you're confused, just write it, no? Expectation of y, if you want. Y bar means expectation of y only, no? What do you know about y? Bx. So if you want to find expectation of bx, expectation means what? Whatever function you're talking about, write it here. What is the random variable here? X is the random variable, so multiply with the PDF of x. So b is a constant, you can put it outside the integration. The remaining thing is integration of x, fx of x dx, which is nothing, looking like expectation of x or x bar. Same thing. X bar or expectation of x, both are same. Similarly, how about expectation of y square? Same procedure. What do you know about y? Just substitute that, bx whole square. B square, you can put it outside. All constants, we can put it outside the expectation. How about sigma y square? Same funda, no? So what is meaning of sigma y square? Y minus y bar whole square. This is the meaning. First write the meaning, and then what do you know about it? Substitute that. Y is bx minus y bar is bx bar whole square. So if you can put b square outside, no? And what it looks like is expectation of x minus x bar whole square, which is, so what you should understand is, when you multiply with a constant, what happens is average value also increases by the same constant, right? So instead of talking in terms of random signals, if you talk in terms of deterministic signals also, if you know a signal, the average value of signal is some value. If you multiply that signal with some constant, the average value also increases by the same constant, right? Okay. So similarly, if you multiply a signal with a constant, what happens to the energy or power? Energy or power increases by constant time. Constant whole square, right? Correct? So energy or power, whenever a signal is multiplied with a constant, its energy or power increases by constant whole square times, right? So the same applies here also, same result we got here also. So if a random variable is multiplied with a constant, it mean increases by b, same constant times. It's variance. Variance is what? Total power. Variance is AC power, and mean square value is total power. We know when a constant is multiplied, total power or IC power will definitely increase by constant square times. So that is what is happening here. So you don't need to remember things. Okay, if you have understood, you don't need to remember anything. There is nothing to by heart here. Okay, don't by heart. So now what happens? Can you tell me in a common sense way what happens when a constant is added to a random variable? What happens to the mean? Expectation of y you want. Okay, expectation of y, just apply whatever you know, you just apply. What is given about y? Just x plus c. So I apply expectation on x and expectation of c. What expectation of x is expectation of x only, because no other information is given about x. If some more information is given about x, we can substitute here. There is no extra information given in this problem. So plus expectation of constant is same constant. So it will be just c. Mean, if a constant is added to a signal, its DC value also will increase by the same constant. Now, if a DC value is added, will the AC power change? If a DC value is added to a signal, only DC power will change. No, why will AC power change? Correct? With that common sense, can we understand This is AC power. No? This is also AC power. No? If you think of X and Y as some current or voltage, there is nothing wrong in when you're doing problems. There is nothing wrong in assuming X and Y as some voltage or current kind of random variables. There is nothing wrong in that. Okay, so when you add DC value, there is no change in AC power, which means there should not be any change in variances. So it should be, they should be exactly equal. There is no extra term here. Okay, so how about mean square value? Mean square value means total power. Since DC power has changed, total power also will change. And how do you find that easily? You can go with regular procedure, the way we have done here. Same procedure you can do for all these problems, but you can find out easier procedures also. So how do you find y square bar? It is equal to sigma y square. This is total power of y is AC power of y plus DC power of y, right? So what is AC power of y? It will not change. And how about DC power? DC power has changed. No, x bar plus c is the DC value. If you square it, that is the AC power. So mean square value has changed, but only thing that did not change is AC power or variance. So mind this point, the variance value will not change because of addition of a constant, because variance means AC power. DC value will only change DC power, not AC power, which means it will not change variance. Beautiful point. This is the beautiful point. Beautiful observation. Don't buy hard things. Understand things. Digest things. You'll not forget. Okay. One more last thing. Shall we? Moments. Other problems regarding moments are easy actually. So these are like little crucial points. If you can apply these things when a problem is given, it can be a little quicker. How about this one? Could you tell me the relation between y bar and x bar? I think it's easy. A into x bar plus b. Correct? Next, can you tell me about variance first? Using previous two results, can you tell me? Using previous two results, can you tell me? Addition of a constant should not change variance, no? There is no impact in variance because of this part, because DC value addition will not change variance. But constant multiplication will change the variance by constant square times, right? So which is a square times sigma x square. Can we say that? Very good, wonderful. Next, expectation of y square. How about that? If you want the total power of y or mean square value of y, you can find it as sigma y square plus y bar whole square. So sigma y square, we know it is a square into sigma x square plus ax bar plus b whole square. For a given problem, you can substitute x bar value, sigma x, and all those things. Okay. So this is one of the points that I wanted to cover. I hope this point is clear. When a random variable is changed in this manner, linearly in this manner, addition of a constant, multiplication of a constant, or both, you should be able to find these moments very easily. Okay, so you can find other moments also easily, not a problem. So let me take a PDF. If x is a uniform random variable, if x is a uniform random variable which takes values from a to b, then find, first question, first plot fx of x and then plot capital Fx of x, which means this is PDF and this is CDF. Third thing is how about expectation of x. Fourth one, expectation of x square. Fifth point, sigma x square. Sixth point, expectation of x power 4. I think I forgot to mention a point here, but it's an easy point actually. Expectation of function of x. I did not write it, but I told you previously. Any function of x. Function of x means what? It can be sin x, it can be cos x, it can be x square, x cube, it can be any function of x. Whenever you want to average this function happens with the same probability as x. So what do? Whatever you want to average, take that first. How do you find averaging? Take whatever you want to average, multiply them with probabilities, and just add it up, right? So with what probability this happens? This happens with the same probability as x probability. Just to avoid confusion, I'll take it as g of x, okay? Because f of x is the notation that we use for probability density function. So just to avoid confusion, you can use g of x. So what do we want to average? We want to average g of x function. G of x takes different values with same probabilities as x. Like g of 1 happens with the probability of x equal to 2. G of 2 happens with the probability of x equal to 2. So you just need to multiply g of x with the probabilities of x only, which is fx of x. Whatever function you want to find expectation of, or whatever function you want to find average of, take that function, multiply it with probability density function of the underlying random variable, whatever is the basic random variable inside this. Take that random variable's PDF and multiply it, and then do integration if it is a continuous random variable, or if it is a discrete random variable, do summation. As simple as that. Any function, let it be any complicated function, x cube, x power 5, x power 100, anything is fine. Any complicated function, sin x into x, x into sin x, x into cos x, any complicated function, same funda. So can you quickly tell me these things? So can you quickly plot the PDF here? From A to B, x takes values from A to B. Whenever some people say uniform random variable, which takes values from A to B. So which means random variable takes values from A to B in a uniform manner, which means with equal probability. Whenever they say uniform random variable, it takes values with equal probability. Equal probability. So this is how fx of x looks like. So can anyone tell me what is the height? What is the width here? Width is highest minus lowest will give you the width, which is b minus a. So the height should be 1 by b minus a. For a uniform PDF, it's very easy to tell the height. Fx of x is equal to 1 by b minus a for a less than x less than b. Correct? Huh? So this is the mathematical way of represent mathematical equation of the PDF. This is the graphical representation. Okay. How about the CDF? Fx of x is equal to, if you integrate this, it is 0 till a. If you integrate, it becomes 0, x less than a. And from a to b, the constant integration will become x divided by b minus a for a less than x less than b, and it is equal to 1. After b there is nothing to accumulate, so it will become 1 for x greater than b. This is the CDF. If you plot it, till a there is nothing to integrate. After a, it's linear function, and after that it will remain constant. So whenever uniform PDF appears, it should be very easy for you to plot these things. And how about expectation of x? Second step, Madhu. This one. Okay. So this one, right? So what is a constant here? From a to b, it is a constant, something like some constant like 2, 3, something like that. 1 by b minus a. A and b are constants. 1 by b minus a is also constant. When you integrate a constant, what happens? Integration of a is ax. Something like that. So the constant is 1 by b minus a. Integration is 1 by b minus a into x. Integration of 2 is 2x, no? In the same manner. Okay, so you should be really good with integration, or by common sense also you can do that. Okay, so from minus infinity till a, there is nothing to accumulate or nothing to integrate. If you integrate also, area will be 0. From a only, integration will give us non-zero results. So if you integrate, what happens? Constant integration will result in linear thing, linear function. Is this not a linear function? It is similar to something like some Cx kind of function. Instead of C, we are having 1 by b minus a. Okay, since it's a linear function, y equal to mx plus c kind of function only, no? That kind of function. One second, I think I have done a small mistake here. Yeah, I think I've done a small mistake here. I think the function that I've written is not correct. Right. See this one in a common sense way. In a mathematical procedure, you can, if you whatever expertise you have, you can use that to integrate. So in a common sense way, from a to b, since constant, it is a constant here. If you integrate, it will become linearly increasing. So if you look at this as y equal to mx plus c form, so you can look at it as a straight line with a slope of 1 by b minus a. This constant here, the height here will become slope here. So y equal to mx plus c form, if you observe, in the place of slope 1 by b minus c will be there. 1 by b minus a into x plus c. What is the constant here? It is y intercept here. Whatever is the y intercept here, that you have to find out here. That you have to find out. That y intercept you can write here. A less than x less than. Okay. Or there are other ways to find y intercept also. Using the other ways also you can find it. Using any procedure that you are comfortable, you can do that. Finally, it will turn out to be, once you find out the y-intercept and if you combine them, it will turn out to be x minus a by b minus a, something like this. For a uniform PDF, it will be linearly increasing. In the duration in which the uniform PDF exists, it will be linearly increasing, and after that it will remain constant. So this is equal to 1 for x greater than. And how about expectation of x here? Integration of x into fx of x dx. Just substitute the PDF equation 1 by b minus a here. If you integrate, it is integration from a to b x into fx of x. You can substitute as 1 by b minus a is the equation in the region from a to b. If you integrate, it will be x square by 2. If you substitute everything, it will become a plus b by 2. I'm just writing the answer. You can do the calculation yourself. Okay, Madhu, I hope you are following. So expectation of x square, same funda, integration of x square into fx of x dx. So if you do the integration, the answer will be something like 2 by a square. So similarly, if you do sigma x square, you can find it in two ways. You can find it as expectation of x minus x bar whole square, or the other way is, look at this as AC power, which is equal to total power minus DC power. That way also you can find it. One mistake. One second. Not 2 by a square. So sigma x square is b minus a. The result will be something like this. You can integrate and see, you'll get the same result. B minus a whole square by 12, and expectation of x square will be a square plus ab plus b square by 3, something like this. Similar expectation of x power 4. So these results I would expect you to remember: mean square value, and variance, because uniform PDF is a regularly used PDF. For many problems you will find uniform PDF, uniform random variables. So whenever a problem is given on uniform random variables, you can reuse these results. If at all, if you forget also, it will not take much time, half minute or 1 minute, you can get back the results. Okay. Saivamshi, yes, I'm from Andhra Pradesh. So this kind of higher order expectations, don't remember, never remember the results, it's not required. So you can do them directly. X bar 4, whenever whatever you want to find the expectation, find it, multiply it with the PDF. You know the PDFs, just substitute them and just integrate. You know the integrations, you're good at maths, I know that. So just substitute fx of x is 1 by b minus c in the limits from a to b, just integrate it, you'll get some little complicated result. My point of giving you this question is, any expectation of any function can be done. That is the point I wanted to convey. Okay. Fine. So I wanted to stop at this place. So we'll wind up for today. So in tomorrow's class, we'll discuss more problems on random variables. So in tomorrow's class, preferably I'll discuss problems on two random variables. Like what if you add two random variables, z equal to x plus y? Then how do you find the PDF of z? Or any problem based on something like this. I'll discuss problems like this, z equal to x plus y, where x and y are two independent random variables and x and y are having some PDF. If they give us questions based on z, like probability of z less than 2, probability of z greater than 2, something like that, we can discuss those kind of, we can after tomorrow's class you'll be able to deal with those problems. Similarly, z equal to x minus y, or z is equal to 2x plus 3y. So any linear relation between two random variables, I'll be giving you the capability of solving that kind of questions. And another model that I'll be discussing is z equal to maximum of x comma y and z equal to minimum of x comma y. So if they are talking about these kind of functions, if they are framing problems on, they give us information of two random variables and they are mixing them in this form, max, minimum, plus addition or subtraction kind of. If they're combining, then any problem based on that you'll be able to solve. I'll be giving you a quick revision on concept, and we'll be doing problems also based on that. Okay, I hope I'm of value addition in today's class for you guys. Any inputs if you want to give, it will be appreciated. So any doubts you have, you can definitely discuss on my Telegram group, Electronics by Dinesh Gutha sir. You can type, you'll get the group, you can join in the group. Any doubts if you have in any topic of communications and signals, you can ask me. Okay, so I want to stop at this place then.